Fine-ELEC has a friendly, familiar user interface. In the program we can find all the classic CAD commands, but also the commands that are needed to make the drawing of our projects very easy and fast. In this video we will see how to design and calculate a typical network of a building. The same procedure and method can be done with any type of building regardless its size and type. Very large projects can be simulated without any problem in the drawing or the calculations. First of all, a new project is created by giving its name. When we create a new project, a folder with the BLD format is created, and inside that folder, the DWG format drawing is placed. The folder and the drawing share the same name of the project. If we have some architectural designs, we can place them as external references. In the project drawing we can execute the building definition command from the definitions menu. With that command we can define the levels of the building. In the window that opens, the name, elevation, height, and external reference of the level is filled in. As it is shown, the external references are placed in the same coordinates for both levels. From the building entities menu we can design the building shell. In the specified video we will not see how we can design the shell, but you can see it on the link on the description. The first step is the placement of the receptors. In order to place the receptors in the desired height, select current elevation. With that command we will set the height in which the receptors will be placed. In the window that opens we can select the block that is going to be inserted, and just by clicking on the drawing the block will be placed. We can also use some automatic commands, but in order to use those commands the building shell must have been defined. It is possible to install a luminaire automatically in a room with defined space in the plan view, and more specifically to install it at a space's center. Of course the user can proceed to any modifications. With the receptor grid command we can select a rectangular, inside of which the receptors will be placed. It is possible to install the receptors automatically in a room with defined space in the plan view. The command requires that there is a door that opens inwards in the room. Then, the receptor is placed on the side of the wall that is opposite to the door hinges. Usually, this command is used for switches. As we can see, the receptors have been placed on the height that we have set it. The second step is the placement of the cables. In any case, the cabling drawing is carried out exactly as the line drawing in any CAD program. The user is able to draw horizontal network segments. Modification of the cable installation elevation is possible through the ribbon menu with the command current elevation. The cable on the distribution board must be connected with the node snap. This command enables you to select the receptors to be connected to an already existing cabling. The program draws network segments from the receptor connection point vertically on the existing line. Some more useful commands about cabling are the following. Cabling parallel to wall, cabling parallel to points, cabling parallel to wall, or points, and receptor connection, and multi-cabling. With those commands the drawing can be faster and easier. This option allows the line name display in a receptor and its correspondent switch. The user can write a text in an easy way and place it next to the luminaires and their switches. After we finish the cabling of the second level, we can continue with the first level. With the same procedure we can add the receptors and the cables. The program can recognize only one supply point. So we need to place one theoretical distribution board and connect it with the other boards. Now we need to connect the two floors with a theoretical distribution board. In the first level very easily we can draw the cable. Drawing vertical segments that cross floors is possible through the option vertical cabling. When this option is selected from the menu, the program asks for the vertical cabling position, enter XY location, and then for the height of the starting point, as well as the height of the ending point. At last we need to connect the theoretical distribution board with the supply point. Symbols include various general symbols, configurations, and other drawings that can be used in the electrical installation. Once a network has been drawn according to the rules stated above, and the supply point has been defined via the respective command, then the network recognition option converts the network into a mathematical model, which updates properly the calculation sheet. Through the recognition, the distribution panels are named on the ground plan. During network recognition, there might appear some warning messages indicating design mistakes for the user. Select the calculation command to open the calculation module of the program. First of all, from the Files tab select Update from Drawing. By selecting this option, the project calculation sheets are updated with the drawing data. The project info refers to the titles and headings related to the project ID. The Network Options dialog contains the main parameters of the installation. More specifically, we can change parameters like the maximum voltage drop, type of cable, short circuit calculation method, and many more. In case the user has selected the method of calculation according to IEC 6364 standard, then the following information on the cables of the specific installation has to be defined. By using this table, the user can define a set of typical load types to be used as templates. For each typical load type, the name of which is inserted in the first column of the relevant screen, the following characteristics can be provided. Calculation sheet is the main window of the program. Each row of this sheet corresponds to a different network segment, while each column refers to the data that will be provided or result automatically during the data insertion procedure. In the line type column, we can change the number of the phases of each segment. The program automatically chooses a different phase for each segment. After pressing F5, the relevant window from the selected line is being activated. On that window, parameters like the line diagram, the number of cables core, the type of cables, etc., can be defined. Regarding the line diagrams, they can be displayed by pressing or selecting F3 or panel single line diagram from the list that appears by pressing the right mouse button on any column of the corresponding row, while in the same manner, the total panel single line diagram appears as long as you click on a panel row. Based on the data entered in the calculation sheet, all data are automatically calculated for each panel separately. To return to the calculation sheet, you should press F7 again. From the calculation sheet, we can export the panel and short circuit segments to DWG or link them automatically to AutoCAD or 4M CAD. This option checks every line of the circuit about its cable cross-section and fuse. If the program cannot calculate for any reason these two parameters, there is a warning for the user in this window. As far as the selection of the substation is concerned, the values that appear on screen should be properly filled. Then the required load is automatically updated, whereas the rest of the values are automatically calculated after selecting transformer type from the libraries. In order to select the fan for the ventilation of the substation, if required, the respective window needs to be completed. This command refers to the distribution diagram of the panels, showing the name specified in the panel calculation sheet. The total voltage drop appears in detail, for each line of the electrical network, from the main panel to each final consumption point. The value of the voltage drop is provided in volts and in percentage. This window shows a detailed list of the materials used in the project along with their quantities, the total costs, and the grand total. In the technical description, the user can see a text updated with the project's results. At last, all the printouts can be linked to Word or be exported to PDF. The typical view of a printout is the following. Now, let's save the calculations and return on the drawing. This option is used for the automatic updating of the ground plan's views with the required information from the calculations. By using this command, the earthing conductor can be drawn. By pressing the button points, the program asks for the successive points for the conductor's drawing. Having selected the last point, the user presses the right mouse button in order to have the design finished. By pressing the button sign, the program asks for the earthing conductor sign's insertion point. With the Create Panels diagram, the diagram will open on a new DWG file, and the drawing can be modified. So easily, an electrical design can be made with all the calculations and all the drawings that we need. Very fast and easily large projects can be made with high precision on the calculation results. For more information, visit the 4MSA website and download the 30-day trial version of the program. Thank you for the attention.